Welcome to our new unit. Now we're going to be talking about polar functions. Polar functions are new. We haven't seen anything really like them in the past. What we are used to is we're used to working in the Cartesian plane or in rectangular form. What that means is when we were plotting our points, we always just moved left, right, up, down. Left-tangular. Rectangular movements, okay? And our points were always in terms of x and y. So when we went to plot a point, let's say we had the point 2, 3. That meant I went 2 to the right, up 3, and there was my point. Very rigid movements. So what we're now going to be looking at are polar functions. Polar functions actually work in radius and theta. Okay, so again, this is radius and then an angle of rotation. A little different, right? So how that works, instead of having our left, right, up, down movement, our plane is actually made up of circles. Kind of looks like a target here, right? So when I'm saying a radius, this circle has a radius of 1. This has a radius of 2, 3, 4, and as I build out. And then I can rotate around that circle a certain angle. So, for example, let's say we have the point 2, 5 pi over 6. So what that means is my radius is 2, so I'm going to go to my 2 circle, and I'm going to rotate 5 pi over 6. And if you remember our unit circle, we know where that is. 5 pi over 6 is about here. So I started here at 2, and then I rotate around that circle to 5 pi over 6. Pretty straightforward, right? The reason we have, or we're going to call this polar, is our origin over here, our point 0, 0, we would call that the origin. But here, instead of calling it the origin, this point is actually called pole. So like North Pole, South Pole. Right? Kind of cool, right? All right, let's do another point. Let's say we're going to have negative 3 pi over 4. So what that means is I'm actually going to go to the left to my negative 3 radius, and now I'm going to rotate 3 pi over 4. So that's 1, 2, and that point is going to land here. Not too shabby, right? One of the cool things about our polar coordinates is we can represent the same point in an infinite amount of ways. Okay? Lots of different ways. But let's look at 3 specific examples. So let's say I'm looking here at my point 2, 5 pi over 6. Well, let's say I were to rotate or start at negative 2 with my radius. That point's a lot closer, but I'm rotating backwards pi over 6. So that is a second way I can represent that same point. Another one, let's say I went to 2, but instead of rotating in a positive rotation, I rotate negative. So that would end up being 2 negative 7 pi over 6. So 1, 2, 3, 4, 5, 6, 7. So I'm rotating backwards. It's the same point, but our coordinates here look different, right? There's one more. Let's say we have negative 2. So I'm starting here. I can't rotate backwards now. I have to rotate all the way around. That's going to be 11 pi over 6. All 4 of those are the exact same point, but the coordinates are different. We can't really do that on our rectangular form because the point 2, 3 will always be the point 2, 3. There's no other way to move. Nifty, right? All right, let's do the same thing for negative 3 and 3 pi over 4. So let's say I'm here at 3. That's a negative pi over 4 rotation. That one's pretty easy to find. Let's do our positive 3 again. Now we've got to rotate all the way back around. That's 7 pi over 4. Which means I need another negative 3. So if I start here, We already did the positive rotation, so now I'm going to have to rotate backwards. That's going to be a negative 5 pi over 4. So if you're used to your unit circle and how those play together, we can see here the negative 5 pi over 4 and the 3 pi over 4. 3 and 5 is 8. That's 2 pi over, or 8 pi over 4, that's 2 pi, right? Same thing here, our 7 pi over 4 and negative pi over 4, that's together, if we don't count the negative, 8 pi over 4, which is 2 pi, our full circle. Okay, so this is an introduction into our polar coordinates. Our next video, we're going to talk about how we can convert between rectangular and polar and vice versa. Okay, I don't know what I just winked. See you in the next video, guys.